We're here at UCSC and we're standing under an Acer macrophyllum tree. From where you're standing, it may look like a perfectly healthy tree, but from where I'm standing, I can see that it's infected with thrips.
Okay, and what we would like to know about these thrips here is what kind of physiological effects they would have on a healthy tree such as this maple.
So in order to answer that question, we're going to be studying three different things. We will be taking measurements of chlorophyll content, water potential, and stomatal conductance of healthy leaves versus leaves infected with thrips.
Insects on the order of Thysanoptera are considered thrips. And two suborders exist as well, called Terebracea and Tubulifera, that differ in the morphology of their ovipositors. In California, Terebranchia, Aeolothripidae, Myrothripidae, Heterothripidae, and Thripidae are most common, but all kinds of species of thrips are ubiquitous across the globe. They cause much more damage and are harmful to trees, not just on campus of UCSC, but agriculturally across California, causing extensive crop damage, serving as vectors that carry viruses that cause disease, and cause huge outbreaks that require extensive and serious pest management. They also occupied a wide range of niches that reflect thrips' diverse lifestyle and feeding preferences.
In order to gain insight into how thrips affects plant function, we first measured the stomatal conductance of 20 thrip-infested leaves and 20 healthy leaves using a calibrated barometer, which gave us insight into the amount of gas exchange each leaf was able to perform. Then, the leaves were collected for further analysis. A chlorometer was used to measure chlorophyll content, which is a large determinant of photosynthetic capacity and growth of a plant. Lastly, a pressure bomb was used in order to measure the water potential of healthy leaves compared to leaves with thrips.
After obtaining the data taken from measurements, we were then able to find out the lowered efficiency of the maple tree leaves compared to the leaves infected with thrips. With our data inserted into a spreadsheet, we were clearly able to see how much of a difference the thrips made. In comparison of chlorophyll content, the leaves that were not infected with thrips were on average contained 4 times the chlorophyll content. The uninfected leaves contained nearly double the water potential as the infected, along with higher rates of stomatal conductance.
By analyzing the physiological effects thrips has on maple trees here at UCSC, we can only begin to understand the major ways it affects plants worldwide, including impacts it has on agriculture. By further analyzing how these insects can so negatively affect photosynthetic rates, we hope to find ways to prevent infestation of these insects in both our local maples as well as plants around the world.